Good morning, 10th standard. We have started with chapter number 15. I have already shared a video in which I have introduced you to this chapter, what probability is and what are the various terms which we use when we are solving questions based on probability, types of probability. Then we also discussed what a sample space is, and there were certain facts that I told you that you need to remember about probability. Now, using those results and the facts, let us do exercise 15.1. Now, in 15.1, there are some questions which have just theoretical explanation, and whereas some questions require actual solving. So let us do the questions beginning from the first one. The first question of the exercise is just a fill in the blanks question. Complete the following statements. So what we have in the first part is, I hope you all have your books with you. It will be better if you open your books. Page number 308. Exercise 15.1. So what I have here is, the first blank is probability of an event E plus the probability of the event not E. So any event E and not E, they are talking about complementary events. So the probability of something happening plus the probability of something not happening. The sum of the probabilities is 1. So the answer for the first blank is 1. Second one, the probability of an event that cannot happen. So an event that cannot happen at all, is impossible event, and its probability is 0. And further they are asking such an event is called. What do we call such an event? Such events are known as impossible events. Third part, the probability of an event that is certain to happen. Now the word certain to happen mean sure, 100% sure, and such event is called blank. What is the probability of event which will definitely happen, and what do we call that event? The probability of that event is 1, which is sure to happen, and the event itself is called certain event or sure event. Fourth part, the sum of the probabilities of all the elementary events of an experiment is dash. Now this also I discussed in my previous video, in which I had taken an example, a bag containing different types of balls. There were some yellow balls, some red balls, and some blue balls. We had written the probability of each of those balls: probability of getting a red ball, probability of getting a yellow ball, probability of getting a blue ball. And when we add the probabilities, the sum came out to be 1. So this is what we have. If for any experiment each of the outcomes is noted down, and then we write down the probability for each of those outcomes are referred to as the elementary events, and the sum of their probabilities is always 1. You don't have to add the outcomes, you have to add the probabilities of the outcomes. The sum will be 1. Fifth part, the probability of an event is greater than or equal to dash and less than or equal to dash. Now this is also based on one of the facts I discussed in my previous video. The value of probability ranges from 0 to 1. The minimum value that it can take is 0, and the maximum value it can take is 1. So that means the probability will either be 0 or more than 0. So greater than or equal to 0, it can be equal to 0 or it can be more than 0. On the other hand, if we go to the higher side, the value of the probability is either equal to 1 or less than 1. Now, question number 2. This is also now a theoretical question. This will only enhance your understanding of the concept. Let us discuss. Question is, which of the following experiments have equally likely outcomes? So if the following experiments are performed, as many times. So number of trials could be as much as we want. We want to find out whether the outcomes are equally likely. What basically we are trying to find out is, if any of these experiments is performed say 100 times, then its outcomes have same probability. All its outcomes have the same probability. For example, I discussed the term equally likely outcomes. Equally likely outcomes means for any experiment, if the outcomes have equal chance of happening, they have same probability, then we say that the outcomes are equally likely. For example, tossing a coin. If you toss a coin, there are two possible outcomes. One is heads and the other one is tails. If you write down the probability of getting a head, the probability of getting heads is 1/2, and the probability of getting the second outcome, which is tails, is also 1/2. In this case, we say that the outcomes are equally likely because the probability, the chance of their occurrence is same. Now you have to do the same in 4 experiments mentioned here. Now these experiments could be performed as many times as you want. So keeping that in mind, let's answer this question. A driver attempts to start a car. The car starts or does not start. Now if you just look at this statement, whether the car starts or the car does not start, this might confuse you with the fact that this is a case of equally likely outcomes or not. You need to consider the number of trials the driver could perform and what kind of car he is attempting to start. So there are various factors that get involved here. So let us say the driver tries to start 100 different cars. So he tries to start 100 different cars. Some of those cars could be new, some of those cars could be old. Maybe some of them are in pristine condition and they work completely fine, and some work at times and some don't work at all. So based on that, if you write down out of those 100 cars he attempted to start, how many cars started and how many did not, you cannot be sure that the outcomes were equally likely. The cars started and the cars did not start, the probability will be equal. You cannot be sure about that. So first case is not a case of equally likely outcomes. Second case, a player attempts to shoot a basketball. She or he shoots or misses the shot. Now obviously if any person tries to shoot a basket, that means there will either be a basket or it will not be a basket. The person gets the shot or misses the shot. So if you just look at this part, again, you might think that this is equally likely outcomes. But consider the number of trials the player could perform. Now there are some factors to be considered while we look at the trials made by the player. What kind of player he is, whether he is a professional player or he's an amateur, or the person doesn't know anything about basketball like me, for example. Second thing, from where is he trying to shoot the basketball? Is he in the court? What's his location? So based on these facts, let us say the person tries 100 times. Can you be sure that out of those 100 tries, 50 times he will shoot the basket and 50 times he will miss the basket? No. Again, you cannot be sure that this is a case of equally likely outcomes. So the answer is no. Now let's look at the third statement. A trial is made to answer a true-false question. The answer is right or wrong. Now this one is a case of equally likely outcomes. Consider 100 questions for which the possible answer is true or false. So every time a person tries to answer those 100 questions, there is the only every time a person tries to answer any of those true-false questions, either of two things will happen. The answer will either be true or the answer will be false. So in this case, there is no other possibility here. There is no other possibility. The answer will either be true or the answer will either be false, irrespective of the knowledge of the person, whether or not the person has any knowledge about the topic or not. He will guess the answer. Either his answer is going to be right or his answer is going to be wrong. So every question he tries to answer, there will be 50-50 chances of giving a correct answer and giving an incorrect answer. So that means this is a case of equally likely outcomes. Fourth part, a baby is born. It is a boy or a girl. Now, this is a universal truth. When a baby is born, there are two outcomes. Either the baby is a boy or the baby is a girl. The chances of that happening, that the baby is a boy, and the chances of happening that the baby is a girl, both the outcomes have equal chances of occurrence. In this case, the outcomes are equally likely. Now, based on this, the concept of equally likely outcomes, we further have a question. Question number 3, which is why tossing a coin is considered to be a fair way of deciding which team should get the ball at the beginning of a football game. Now, why do you think a coin is tossed when a game is started? Because when a coin is tossed, one team chooses heads and the other chooses tails. And because the probability of getting heads and tails is equal to each other, they have 50% chance of happening. We will get heads or we will get tails. Each of these outcomes has a 50% chance of occurrence. They have equal chances of occurrence. That's why both teams have equal chance of beginning the game. That's why tossing a coin is considered a fair way. Now, every time we deal with questions, you will come across a term where they say that the coin tossed is a unbiased coin. So unbiased coin is one in which there is no cheating. So like a standard coin, one side will be heads and the other side would be tails. There's no cheating with the coin done. Continuing further, question number 4, which of the following cannot be probability of an event? You have been given some numerical values. You have to tell whether this can be a possible value or the answer for probability or not. So we will use the fact that the probability ranges from 0 to 1. It cannot be below 0, it cannot be more than 1. It always stays between 0 to 1, 0 and 1 included. So a simple way to remember that is either the probability will be 0 or it will be 1 or it will be somewhere in between 0 and 1. And when the probability is between 0 and 1, that would mean the probability is a proper fraction. So if you have a fractional value, look for it as a proper or improper fraction. First one, 2 by 3, it's a proper fraction. So yes, this can be a possible answer. Second, minus 1.5, probability cannot be negative. It cannot be below 0. So this is not probability of any event. Then we have 15%. 15% means 15 over 100. Again, this is a proper fraction. So yes, this can be probability of an event. Then D part, 0.7. 0.7, if you look at the decimal value, you can tell that this is more than 0, less than 1. Or if you write it in terms of a fraction, so this is 7 by 10, which is a proper fraction. So yes, this can also be the probability of an event. Only one answer is not possible. Question number 5. If probability of an event is 0.05, what is the probability of not E? Now we have the probability of an event. We have to find out the probability of not that event. We will be using the concept of complementary events. So what we know about this is, now this is something we will solve. We will have to write down the answer. Question number 5. Probability of E is given as 0.05. You have to find out the probability of not E. Not E is written as E bar. So this is what you have to find out. And what you know is that the probability of E plus probability of not E is 1. Use the value here, 0.05 plus probability of not E equals to 1. This will be equal to 1 minus 0.05. This will be 0.95. Question number 6. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy, a lemon flavored candy? Now usually to find out probability we need the total number of outcomes and the number of favorable outcomes. So we want to know how many candies there are in the bag. Now the fact here is we are not concerned with the number because the bags contains only one type of candies. It only contains lemon flavored candies. So irrespective of the number of candies in the bag, whichever candy you pick out of the bag, it will always be a lemon flavored candy. And if you're looking for some other type of candy, you will never ever get that flavored candy from the bag because it's not there. So just based on this fact, we can answer these two parts. Probability of getting an orange flavored candy, because this candy is not present in the bag. We will never get an orange flavored candy. So this is actually an impossible event. This is an impossible event. So that means the probability is 0. Second case, we want that the candy should be lemon flavored. So you can pick any candy out of the bag. All the candies are lemon flavored. So every time you pick a candy, if there are 10 candies, you try to take out the candies 10 times. Every time you will get a lemon flavored candy. So this is a sure event and the probability for this is 1. So without even having the total number of outcomes, we can answer questions in terms of their probability. Question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? Now, there are 2 things used in the question just to create a confusion. They are mentioning the number of students and then they are mentioning the probability. Now, what they're saying is that there is a group of 3 students. Okay, then out of those 3 students, 2 students not having same birthday, the probability that 2 students don't share the birthday is 0.992. So if we just forget about the number of students in the group, we just look at the fact that 2 people don't share their birthday and the probability for that is 0.992. What is the probability that they will have same birthday? So this is like question number 5. Something happening, something not happening. In this question, probability of something happening was given. You had to find out the probability of that thing not happening. Here it's the opposite. The probability that the students don't have same birthday is given. You have to find out the probability that they have the same birthday. So you will use the concept of complementary events. So this will be probability students have same birthday plus probability students do not have same birthday. The answer will be 1. So this is probability of event plus probability of not the event. So this is not given. This is something you have to find out. So probability of same birthday plus this is given as 0.992 equals to 1. Solve. So probability that the students have same birthday will be equal to 1 minus 0.992, which is 0.008. Be very careful with the subtraction. Students generally make a mistake doing this, so do it very carefully. Now let's do the next one. 8th question. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? Second, not red. So to find out the probability of getting a red ball, we will be writing down the total number of outcomes and the number of favorable outcomes. Using those two values, we will write down a fraction. The total will be in the denominator. So you could write the answer directly, or you could give the answer by making a statement. Total number of balls. So there are 3 red and 5 black balls. So this will be 8 balls in all. And probability of getting a red ball. So total is 8, out of which how many are red? 3 are red. So this is the probability of getting a red ball. Now probability that the ball is not red. So event is getting a red ball, not the event. What we will do? 1 minus 3 over 8. Because we want the opposite of this, what we will do? We will subtract the probability from 1. So this comes out to be 5 by 8. Let's take a look at the next question. 9th question. A box contains 5 red marbles, 8 white marbles and 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be red, white, not green? So the box contains 3 different types of marbles. Let's write down the statement and then see what our answer is. So for question number 9th, we have 5 red marbles, 8 white marbles and 4 green marbles. So total number of marbles is 17. The total number of marbles is 17. 5 and 8 is 13 plus 4 is 17. Probability of getting, first part is red marble, so total in the denominator, and out of those 17 marbles, how many are red? 5. So this is the probability of getting a red marble. Then we want to find out the probability of getting a white marble. Out of 17 marbles, we can get 8 white marbles. Finally, we have to find out the probability of not green. So not green will be 1 minus probability of green. 1 minus, what is the probability for green marble? There are 4 green marbles out of 17 marbles, so this will be 4 by 17. You can calculate the answer from here. This will be 13 over 17. You could have also given the answer by calculating from here. If we want the probability of not green marble, you don't want a green marble, you want any other marble, so exclude the green ones, exclude these 4 and take the other remaining marbles. 5 and 8, 13 out of total 17. So these work, these are not green, these are some different color. You can also answer this way, or you can answer this way. Question number 10th. Question number 10th is, a piggy bank contains some 50 paise coins, some 1 rupee coins, 2 rupee coins, 5 rupee coins, and they have told you how many such coins are there. 50 paise coins, there are 100 such coins. 1 rupee denomination, 50 coins. The coins with denomination of 2 rupees are 20, and the coins with denomination of 5 rupees are 10. If it is equally likely that one of the coins will fall out when the bank is turned upside down. Now when they say that there is an equal chance that any of the coins could fall out, any of the denomination coin could fall out, means the size is same. Size of the coins and the shape of the coins is same. If it was different, if there was some other factor involved, like their size or their thickness is different, then they will not have equally likely chance. There would not be the same probability of them falling out of the piggy bank. Since their size is same, assuming that their size is same, in that case they will have an equal chance of falling out of the piggy bank once the piggy bank is turned upside down. So keeping that in mind, what is the probability that the coin which falls out of the piggy bank will be a 50 paise coin, will not be a 5 rupee coin? So first of all, we need to find out the probability of getting a 50 paise coin. So let's write down. So you could make a table or you can make a statement. So I'm making a table here. Denomination and number of coins. So we have 50 paise coins, 1 rupee coins, 2 rupee coins, 5 rupee coins, and then we need the total. Total is always required to write down the answer for the probability. There are 100 coins with 50 paise denomination. For 1 rupee we have 50 coins. For 2 rupees we have 20 coins, and for 5 rupees we have 10 coins. So counting from here, there are a total of 180 coins. And in the first part, we want to find out what will be the probability of 50 paise coins. So total 180, out of which how many 50 paise coins are there? 100. So you can simplify or you can leave the answer in this form. This will be 5 by 9. You can leave the answer as such, 100 over 180, that's fine. Then we need to find out the probability of not 5 rupee coin. So now, just like the previous one, not green, you could either do it by writing this 1 minus probability of getting 5 rupee coin, or you could write the answer for this as count the other coins. So this will be out of 180, exclude 5 rupee coins. So exclude these 100 coins and take the other 3. So taking the other 3, 100, 50 and 20. So 150 and 20 will be 170 over 180. Let's see what the answer from here comes out to be if we were using this. So this would be 1 minus 10 over 180. Probability of getting 5 rupee coins. Out of 180 coins, there are 10 coins of 5 rupees. The probability of getting 5 rupee coins will be 10 over 180. We want the probability of not getting 5 rupee coins. So we will subtract this probability from 1 and the answer would still be same. This will also be 180 minus 10 over 180. In either case, the answer is 170 over 180. In either case, from here or from here. So you can do any of the two methods. Let's take a look at the next question. 11th question. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. Figure is given. So there is a tank and Gopi is trying to take out fish from that aquarium. there are 5 male fish and 8 female fish, and what is the probability that the fish taken out is a male fish? So there are total 13 fish in the aquarium, out of which 5 are male. So this is simple. The answer would be 5 out of total 13. So 5 by 13. Let's take a look at question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers. So this is the wheel, spinning wheel. It has been divided into sectors. The sectors are numbered from 1 to 8, and there are no two sections with the same number. One number has one sector. So there is one sector marked with 1, one sector marked with 2, one sector marked with 3, one sector marked with 4, and so on. So all of these have equal chance of occurrence. If there was a number repeated in more than one sectors, then there will not be equal chances of getting those numbers. In this case, these numbers, 8 numbers, have equal chances of appearing. And they have mentioned that these are equally likely outcomes. What is the probability that it will point at 8? So out of the 8 sectors, total 8 sectors are there, out of which there is one sector with 8 on it. So total paths are 8. This will be the denominator, and for 8 there is only one part. So one part has 8 marked on it. So 1 out of 8. Odd number. Out of these 8, how many odd numbers are there? 1, 2, 3, and 4. Number greater than 2. Out of these 8 numbers, how many are greater than 2? You have to count how many are greater than 2. You don't have to tell the numbers themselves. You have only need the counting. So the numbers which are more than 2. This, and this. So 1, 2, 3, 4, 5, 6. 6 numbers are greater than 2. So 6 out of 8 numbers are greater than 2. A number less than 9. A number less than 9. All these numbers are less than 9. So 8 out of 8. This is a sure event. The probability is 1. This is a sure event.